Hello guys, this video is for actually 2 days of week 4, week day 1 and day 2. I'm going to go through day 1 first, and the title is Inverse of Functions. So first off, a function relates an input to exactly one output. Okay, so you probably have done this back in Algebra 1 when we have two circles and everything from like the left side, if I have 1, 2, and 3, and I don't know, like 1, 3, 1 or something, or 1, 3, 5 or something like that. Whenever we have a 1, we can only map to one item. Okay, and then the 2 can map to also one item. It can map to the same item, but each input, which is the left side, can only map to one thing. Okay, so like if I were gonna do this, that we can't do that. Okay, we can't have a 1 mapping to two things. And then the last thing, we can just map to something random. Okay, but the left side cannot have more than one output. Okay, so this is kind of like what it means by function in the simplest sense. And so far, we have talked about a few types of functions. We have talked about linear, quadratic, cubic, exponential, rational, and this time we're gonna talk about something called the radical function. Okay, and this is the whole entire topic for that. Okay, this today specifically, we're only gonna talk about like how looking at the function or looking at a graph, whether it's a function or not, and whether it's something called the invertible. Okay, so there is something called the invertible function. So first off, let's say if f is a function, because f doesn't have to be a function, but if f is a function, the inverse of f must also be a function. Okay, and we would call that the f inverse of x. Okay, there's like a little -1 on top. Okay, so I'm going to show some graph, and then we're going to check whether it's a function. Check whether the graph is a function. Okay, so I'm going to show 3 graphs. Let's say, let's do one now, click this, and this one right here. Okay, so let's look at the first one. In order for us to check, there's something really special called the vertical line test. So vertical line test is if you drop any straight line down, okay, any vertical line down, you can only hit one point on your graph at a time. Okay, so let's say the first one, if I'm gonna just drop a line down, drop a straight line down, let me draw a straight line. I'm gonna draw a straight line, I'm only hitting one point. Okay, if I drop another line down, I'm only hitting one point. So if you're able to do that wherever you can on this graph, okay, only one point at a time, only one point per straight line, then you can call this a function. Okay, So let's check the second one. If I were gonna drop a straight line down, you would notice that this one we're actually hitting 2 points of the graph at a time. Okay, so I'm gonna point to it and say more than 1 point. So in this case, this is not a function. Okay, last one. I'm gonna drop a straight line down. That one, I see 1 point. Drop another one. That one, it's also 1 point. Okay, and then if you're able to do one that's like more than 1 point, then it's automatically not a function. Okay, but in this case, since wherever I'm gonna drop it, I'm still only gonna hit 1 point, then this is a function. Okay, so this is basically your homework, but I'm gonna go in depth a little bit because this lesson is more about like invertible functions. So remember earlier we said invertible functions is if the function the graph is a function. So like if I were gonna check whether it's invertible out of these three graphs, I would not check the middle one, okay, because I already know it's not a function. So I'm gonna move on to the next page. This one, I have attached some graph to it. These ones right here, they are already functions. Okay, you can check it with your vertical line test. And now I'm gonna use these graphs to check whether it is invertible. Okay, and now checking whether it's invertible, I'm going to be using a test called the horizontal line test. Okay, it is the same type of test, but this time is horizontally. You can only draw horizontal lines, so like these ones. Okay, so the first graph, again, I know it's a function, but is it invertible? I'm going to draw a line directly across. So how many points am I hitting at a time? You would notice that we're hitting 2 points. Okay, actually, no matter where you draw the straight line, you're always going to be hitting 2 points. So since we're hitting 2 points at a time, in this case, this is not invertible. Okay, so not invertible means the function that we're going to do a flip to it is not a function as well. So let me show you how it looks like on the next page. So the red was earlier, and this graph right here is the inverse graph. Okay, so these two graphs right here are inverse of each other, but you would notice that this blue graph right here is not a function. Okay, so let's check the next one. This graph right here. Let's try to draw a straight line across. So right here, you would notice that we're hitting 1 point, but is there anywhere that I'm going to draw my line through that I would hit more than 1 point? Okay, you would notice that right here, I draw my line through. How many points are we hitting at a time? 1, 2, and 3. Okay, so again, if you already have a line that hits 3 points, then I can say this is not invertible. Okay, because we have 3 points hit at one line. Okay, so let's look at how the graph looks like. The inverse graph looks like this, and this is not a function because when I draw a straight line down, I'm hitting like so many points as well. Okay, so they are not invertible. Okay, last one. This is a function, but when I draw a horizontal line, I'm hitting 1 point, hitting 1 point, and hitting 1 point. Okay, so every one of these I'm only hitting 1 point. That means this graph is actually invertible. Okay, when I look at the inverse graph, yes, look at the blue. Blue is the inverse, and it's actually a nice function right there. Okay, so it's invertible right there. Okay, and this is basically it for lesson one. Lesson one, I'm not like you're not doing your homework on any of these invertible or inverse kind of graph. Your homework is just this page right here, and they're only asking you whether it's a function or not. Okay, use the vertical line test. If it is not a if it is not a function, you have to show me why it is not a function. Okay, so point to it and explain why it is not a function. Okay, so I'm looking at this right here. I can tell you that there are two of them that are not a function. Okay, so you try to figure out which ones they are. I am not going to do any of your homework questions because I think I did one just right now. Yeah, okay, so that's it for lesson one. I'm going to go ahead and do lesson two. Lesson two, there are 2 pages on the homework. One of them is for honors. If you want to work on that, you're welcome to work on it and you'll get extra credit for it. For um, that page right there, we are mainly doing radical functions now. And radical functions, let me write the original. So this part right here, radical function have a radical to it, so mainly it's like square roots. Sometimes it's a cube root or even more. Okay, and the function for that, let's try to graph it out using points. If I can substitute any x, and if I were gonna put the square root of x to it. Okay, think about it. If I put a negative number in there, okay, if it was gonna be square root of -1, can I graph that? No, we cannot graph that. So this is undefined. Okay, we are talking about the xy plane. We cannot graph square root of -1. So we are not going to touch any of the negative side for this graph. So I'm going to try to put now like 0 and 1. 0, put it in there. Square root of 0 really equal to 0. Square root of 1 really equals to 1. Okay, so the next number that I should try should be something that when I square root it, it's going to give me a nice number, right? So the next one I'm going to try is 4. When I put square root of 4, this gives me 2. Put 9 in there, this is going to give me 3. Okay, so you're really graphing this comma that, 1 comma 1, 4 comma 2, and 9 comma 3. These are the points that you're graphing. Okay, so let me go ahead and graph this and show you what it means. 0, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, actually I might need more points right here. Extend my line. 5, 6, 7, 8, 9. Okay, so the first point is 0, 0. Next point is 1 comma 1. I'm not gonna graph 2, 3, and then now 4, I'm gonna go up to 2. Okay, 1, 1, 0. And the next point I'm gonna graph is 9 comma 3. Okay, so you would notice that the graph looks like this. It's a curve. It's like half of a parabola sideways, and it's a curve going up slowly. Okay, so for my honors homework assignment, you guys are doing domain, range, x-intercept, and y-intercept. Okay, you are welcome to use Desmos for your homework. because that's like the best way to see how much left it goes, and to the right and bottom and up. Okay, so domain, remember, we're looking from left to right. So if you're looking at the most left point, this graph starts at 0. Okay, and hold on. We are including the 0, so we're going to do a bracket for the 0 because we're including it. Okay, do we know how much right it goes? It doesn't stop at 9, it just goes all the way. So we don't know where it goes, we're going to end it at infinity. Okay, again, infinity it's not a number specifically, so we don't know when it ends. That's why we use like parentheses. Okay, and then for range, what's the lowest number that it goes to? We're not hitting any of this graph, right? So it starts at 0 as well, bracket, and it goes up. Even though it goes up slowly, it's still going up. Okay, so it's still infinite. Okay, x-intercept and y-intercept. Where are the numbers hitting on the x and y axis? It is at 0, 0, and 0, 0. Okay, I'm gonna do 2 examples from your homework. Let's see. Let me do it from the homework paper. Let me do square root of like number 2. Okay, so number 2, let me set up my graph. Remember, originally it goes like that. So if I have a positive 4 in here, inside my function, this is really moving 4 units to the opposite side, which is to the left. Okay, so your new function is going to be like right here, like this. Okay, it can actually go further away. Okay, so for your domain and range, now the most left point would be -4, and again, we don't know when it ends. So I bracket for that. And then for range, lowest number is still 0, and it goes up forever. Okay, and your x-intercept and your y-intercept. Just by looking at the graph, the easiest to look for is your x-intercept because it's already on that point at -4, 0. Okay, so for a y-intercept, we gotta set x equal to 0. Use another color for that because that's work. I'm gonna set the other letter equal to 0. So if I put 0 inside x plus 4, this would give you 2. Okay, so y would give you 2, which means your y-intercept would be 0, 2. Okay, I'm going to do another question, and that would be number 11. Okay, number 11, some of these harder ones down here, I recommend you to look at the Desmos graph. So let me go to right here. I already kind of attached it to it. This is how it looks like for number 11. So if you were going to do your domain and range, x-intercept and y-intercept, your domain, most left, most right. Do these graphs stop? No, they don't. So that means your domain is going to be from -infinity all the way to +infinity. Okay, now from bottom up for range. This one goes down forever. This part goes up forever. This goes down forever. Okay, so that means your range is also going to be -infinity to +infinity. It doesn't have a stopping point. Okay. Last part is your x and y intercepts. You notice that if you were going to zoom into this graph, it's actually at 0, 0. Okay? So your x-intercept is still 0, 0, y-intercept is also 0, 0. Okay, so that's it for this part right here. If you have any question for the honors homework, please let me know. Okay, so I'm gonna go ahead and do the other worksheet, which is really the title is Composition of Functions. Okay, I think that worksheet is the page 4. Yeah. Okay, so this page right here, your job is to check whether f of x and g of x are inverse functions. Okay, so if you have a f of x, let me actually use 2 different colors for these, because it will help from there. I'm going to use red for f of x. I'm going to use green for g of x. Let me remember this green. Okay, so whenever you have your f of x, you have to put the g function in there. Okay, I'll explain what this means later. But if you put your g function into your f function, and if this equals to x, that means they are inverse of each other. Okay, but whenever you put your f function, your g function into your f function, and this doesn't equal to x, that means they're not inverse. Okay, I'll show you some examples that are inverse and that are not inverse. So, example, if I say, oh, f of x equals to square root of x, and I say g of x equals to x squared. Okay, let me actually highlight these. So this is my f function, and this is my g function. So I have to first off check f of g of x. Sorry, it's a lot of color changing, but I think it will really help with this color aligning each graph. Okay, so I'm going to try to put whatever g is inside the f function, replacing anytime you see an x in there. Okay, so you see how the f function has a square root and it also has an x, right? We're not going to write that x. Instead of writing x, I'm going to put whatever g says. G is x squared, so I'm going to put x squared in there. Okay, so the square root and the square get canceled out, and this really equals to x. Okay, again, if f of g of x equals to x, that means they are inverse of each other. Okay, let's try another one. So if I say f of x equals to use red. If I say f of x equals to x squared plus 5x. Okay, and then I have g of x equals to, I don't know, like 2x. Actually, let me use another number. Let's use 3x. Okay, so I want to check whether they're inverse of each other. What we gotta do is we're gonna set up our g of x inside f of x again, which means I'm gonna write how f looks like. You know how it says x squared plus 5x? Instead of writing those x's, I'm going to put parentheses for them. Okay, and what's going to go into those parentheses? Your g function. Okay, so 3x is going to go in here, and 3x is also going to go in here also. Because they are x's, we are replacing our g function into our f function. So if I were going to finish writing this, this is going to be, you have to square each of those, which means it's 9x squared plus 15x. Okay, this is my final result. Is this an x? No, so that means this is not a function, not inverse. Okay. I'm going to show two of your homework questions. Let me just actually go to the homework page. I think this is the homework page. I'm going to do number 2 for you. I'm going to do number 5 for you. Okay, so you got your f function, and you also got your g function. Okay, so remember we're trying to put f of g of x. So let's try to rewrite this. Okay, we're going to try to rewrite f, but f would look like -4 parentheses. We don't put the x in there, and then plus 9. Okay, because the x is going to be replaced by what g is. X minus 4 all over -9. Okay, and then now let's try to solve for this. Just by looking at this, does this look like a function? Do you think it's going to result to be an x? If it is not, then you can prove it to me. So let's keep going. I'm going to put the -4 into each of those, which we get -4x plus 16 all over -9. Okay, plus 9. Since we have a negative at the denominator and we're going to try to add something, I'm going to change that -9 or divide each of the top by negative. So the negative at the bottom can go away. Okay, so I'm going to change the -4x to just +4x minus 16 over +9. Okay, again, I'm doing this because I want all of these signs to change. Okay, and I still have my plus 9. Now, common denominator, I'm going to multiply 9 over 9 because I want the denominator to be a 9. So this is going to be 4x minus 16 over 9 plus 81 over 9. Okay? Keep going. Yeah, it's so obvious that it's not going to be equaling to an x. So it's going to be 4x plus, what is it, 62 or 65? Yeah, 65 over 9. And this is not inverse. Okay, because again, your goal is to have an x. This is not equal to x. So this is not inverse. Okay, let me try to do another one. Let's do number 5. You can pause the video and you can write it on your own and come back to check my answer. Okay, so I'm going to start writing my f function first without the x. Looks like that. Okay, actually, we gotta leave some more space because the g function looks pretty long. So if you can tell, this looks very similar to f function, except I didn't put the x in there. Because I'm going to replace x to the third power over 8 minus 3 in here. Okay, I'm gonna write this 3 a little bit better because this is not a cube. This is a cube root. It goes right there. Okay, keep going. So is there anything I can simplify? So that parentheses, I can actually drop it because I'm adding a 3 in the back. So if I get rid of this parentheses, the 3's get canceled out. So now I have 2 times cube root of x to the third power over 8, cube root of the top, cube root of the bottom. Okay, this part right here actually turns into x because I have 3 pairs of the x. And how many, 3 of the same thing, when I multiply them together, gives you 8. What would that be? 2, right? And I still have my outside 2. And you notice that the 2's get canceled out. I'm down with just a x. Okay, so remember, if it's just an x, that means it is inverse. They're inverse of each other. Okay, so this 2 questions for you. You're gonna go ahead and finish the rest on your own. And that's it for this video. Okay, thank you.